Hi there and welcome. I'm Rebecca Weaver. We're going to be covering section 9.5 today, some applications of the integral in our applied calculus class. We're going to be looking at the Riemann sum. So this is another approximation. The Riemann sum is the integral from a to b of f of t dt. Breaking our sections, our little subsections here into the b minus a over n, just what we have been doing to get that delta x. And they're going to be our selected points for a partition from A to B. So the Riemann sum says this approximation will be f of t1 times that width plus f of t2 times that width, blah, 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 all the way up to your very last one. So if our interest is compounded continuously, A equals, and we call this the PERT equation, our principal times E raised to the RT, where R and T are our rate and T is our number of years the money is growing. A is our amount of money that you end up with, and P is the amount of money that you started with. Thus, the formula for the present value of A, dollars, in T years at the interest rate R is, and just solving that equation so that we have P equals A, e to the negative RT. So the present value of a continuous stream of income, that present value is equal to the integral from T1 to T2, where that's the time period of the income stream, time of KT, and KT is the dollars per year. Now it's the annual rate of income at time T. E raised to the negative RT, where R is the annual interest rate of invested money. And take that integral with respect to T. All right, let's look at another example. Let's find the present value of a stream of earnings generated over the next 2 years at the rate of 50 plus 7t, $1,000 per year at time t, assuming a 10% interest rate. Okay, so using the theorem above, we have k of t is 50 plus 7t, r is 0.10, our t1 is 0, and our t2 is 2 years. So we're going to plug all of this into our formula. We'll get the integral of 0 to 2 of our kt, which is 50 plus 7t, times e to the minus 0.10t. Take that integral with respect to t. To evaluate this, we're going to need to rewrite the integral into breaking apart into sums. And then we'll end up with the integral from 0 to 2, 50e to the minus 0.10t dt, plus the integral from 0 to 2, 7t e to the minus 0.10t dt. Now we're going to evaluate the first integral directly because he's good. But now the second one is going to need integration by parts because of that t that's sitting in there. That's not an easily integratable function there. So what we're going to have is the integral of 50 plus 7t times e raised to the negative 0.10t dt. That's this first integral. We're going to compute that integral. Go ahead and solve it and compute it from 0 to 2. Then you're going to evaluate the integral where you have to use your integration by parts. So we're going to do that integration by parts, evaluating it from 0 to 2. And we're going to end up with 102.90. So the present value of the described stream of earnings is $102.9 thousand. The total population in a ring around the city center is the integral from a to b of 2 pi t d of t time integrated with respect to t, where d of t is the density of a population in persons per square mile at distance t miles from the city center. Now, the ring includes all persons who live between a and b miles from the city center. The population density of Philadelphia in 1940 was given by the function 60 e to the minus 0.4t. So that's going to be our d of t. Calculate the number of people who live within 5 miles of the city. So that's going to be evaluated from 0 to 5. So using this theorem, we have the integral from 0 to 5 times 2 pi t 60 e to the minus 0.4t dt. Evaluating that using integration by parts, evaluating it from 0 to 5, we are going to end up with about 1,400 people. All right, if you have any questions, be sure and email me, rweaver10@alaska.edu. Have a fabulous day.